right, we're going to go ahead now and add rational expressions that have unlike denominators. So the first thing we do is we factor the denominator of both fractions. So the first fraction just stays as x over x plus 2. The second fraction, the denominator needs to be factored by the difference of 2 squared. So we have x plus 2 and x minus 2. Now we want to find the least common denominator of these two fractions. So the first denominator of x plus 2, the second fraction has a denominator of x plus 2 and x minus 2. So the least common multiple, these two are in common. And then we do not have an x minus 2 in the first fraction, so the LCD will be x plus 2 and x minus 2. So that's our LCD. So if we notice this first fraction does not have the x minus 2, so we have to multiply the numerator and the denominator by what we're missing from the LCD. So we multiply both the numerator and denominator by x minus 2. The second fraction just stays as it is because it already has the LCD pieces of x plus 2 and x minus 2. So now we look, both of our denominators are the same. So we'll go ahead and add those fractions together. So we add the numerator. So here's our numerator, we add those together. So we get x minus 2, plus minus 8 just turns out to a minus 8, and then we keep that denominator. Now we're going to go ahead and distribute the x into that binomial. So we get x squared minus 2x, and then we have a minus 8 on the end. And then the denominator, I do not want you to multiply that out. You'll find out later in another lesson why it's nice to keep that denominator in factored form. The last thing is to identify any domain restrictions. We do not want x to be positive 2 and negative 2 because those would make it undefined. All right, here's another example. We want to go ahead and factor the denominator and the numerator. So I'm going to factor the numerator as the GCF of 2. So we're left with x plus 3. And then the denominator, we can do the diamond method. So what are the factors of 9 that add to 6? Well, that will be positive 3 and positive 3. And then plus x over x plus 3. Now before we begin adding these fractions together, we notice there is a common factor. So we can cancel the x plus 3's. So now we have a 2 divided by x plus 3 plus x over x plus 3. What's nice about this is our denominators are the same. We have like denominators. We can go ahead and add the numerators. So 2 plus x. And then the denominator just stays the same, x plus 3. I'm going to go ahead and simplify that numerator. I'm going to go x plus 2 over x plus 3. So here's our answer. And then what makes this undefined? If we look at our denominator, we do not want that x to be negative 3 because that would make that a 0.